Hi and welcome back to Sustainable Teacher. If it is your first time here, my name is Leticia and I'm glad to meet you. And if you've been here before, I'm happy to see you again. In today's video we are going to start with a new topic, which is electricity. And in this video we will review the basics of electricity. So if you are interested in this video, please subscribe, hit the notification bell, and if you like this video, give it a thumbs up. Electricity is a type of energy, is electrical energy, and in reality it's just electrons jumping or going through atom to atom like in a flow. Okay, so this is simply electricity, and we can have like two main types of electricity, which are static and dynamic. The difference between static and dynamic electricity is that usually static electricity is due to friction between two surfaces and is local. It happens only at that point where friction is happening. And dynamic electricity is due to a power source, a power supply, and it can go through a circuit for a long distance. It's not local, okay? But usually when we talk about electricity, we refer to electric current. So that is the current, the flow of electrons inside a conductor like a wire in a circuit. And in the case of electric current, we can have also two main types of currents, which are direct current and alternate current. The difference between them is the way electrons move. In a direct current, they move all the time from the battery all the wire to the battery all the time, like this, in circles, okay? In the case of alternate current, they move for a time on a sense and then they change the sense. There is an alternator instead of a battery or a cell, and they change the sense. They say the direction, but actually it's the sense. They change the sense. So you imagine a circuit like this one, they will be all the time switching from one side to one side, one side, like small steps, but not all the circuit. The thing is that this way, you don't have to understand this, of course, at this level, but the thing is that with alternate current, you can transfer electricity longer distances, and that's important when you have to send electricity to all houses, buildings, etc. I want to tell you a story which is very funny about electricity. When electricity was discovered, we didn't know that the atom existed and the structure of atoms, and that in reality it's electron, the charged particle, that transfer electricity, okay? That is the flow of electrons from atom to atom, the one that produces in the end electricity. And the thing is that when they discovered electricity and they didn't know about the atoms and the electrons, they just decided that the sense of electricity was from positive to negative pole in a cell or in a battery. Years later, when atoms were discovered, when the electrons were discovered and studied, and they discovered that electrons have negative charges, of course they can go from positive to negative because they will repel each other. So in reality, electrons go from the negative pole to the positive pole of the battery, but still we say by convention that the direction of the current is from positive to negative, and that's the funny story. So usually when we talk about electric current, we are thinking of or about circuits, and we have two main types of circuits depending on the position, the connection between components, okay? So we have series circuits when all components are in the same wire in just like one line, and parallel circuits when components are in different wires, in different lines, and all these wires or these lines are parallel. Okay, if you see like the design of a circuit, they will be parallel. The advantage of the parallel circuits is that if one part of the circuit is off or is cut and it's open, electricity won't pass through there, but still will pass through the other parts of the circuits. When I was a child, Christmas lights were in series, and if one of the bulbs, the little small bulbs, died or something, you can't use them, those lights anymore, because all the light bulbs after that light bulb that was broken won't work anymore. Nowadays they are parallel, and that's why they work even if one is broken or something. So just a quick reminder of which type of circuits component can we have. And I've divided them in, I think, 4 categories. Okay, the first one is power supplies. These are the components that give energy to the circuit. And we can have cells, batteries, and also alternators in the case of alternating current. Everyone used a symbol, which are represented in here, and well, if you see like a design or like a map of a circuit, you have to understand these symbols, recognize this symbol to understand what is going on in that circuit. Then control elements are the elements that helps us to control the circuit. Okay, so we have switches to turn it on and off, or buttons. Buttons can work in 2 different ways. They can be normally open buttons or normally closed. It is normally open. When you push it, you connect the circuit and it works, like in a TV or in a computer. If it normally closed, when you push it, you unplug the circuit. Okay, if you want to know an example of normally closed push button, it's the case of fridges. If you see in like in the corner in the door, there is always like a button, and when you push it, the lights goes off, and when the door is open and it is not pushed, the light is on. So this is a normally closed. And finally, we have multi-way switches, which are switches with different positions, and each position will turn on or will connect one different part of a circuit. Imagine that we have a motor, and the motor can go one side or the other sense, like right or left. It has like 3 positions, like the off position, and then if you go right, the motor will right, and if you switch the multi-way switch to the left, will go left. If we have a circuit, is to make something work. So the thing that works are called output elements. They could be light bulbs, they could be motors, they could be bells. They are also called buzzers. It depends on the type of the sound. Or they could be resistor also. Resistor can or just change the voltage or the current in a circuit, or they can transform electrical energy into heat or into light, in another type of light. It depends, okay? So I decided to include them here. And finally, we have protection elements like the fuses, and fuses have a small wire inside, and when there is too much current or like too much electricity in a circuit, it could cause damage to that circuit. The small wire inside the fuse breaks, and that opens the circuit and it doesn't work anymore. To finish with this video, I want to talk about the Ohms law. The Ohms law is the equation that relates the 3 main components that characterize a circuit, which are voltage, resistance, and current, or intensity. The voltage is a difference of electric potential, like a difference in charge between 2 points. The current, or intensity, is the rate, like the number of electrons passing through a point only one point in a circuit. That's the rate, okay? And the resistance is the tendency or the ability of an object inside of a component inside the circuit to avoid electricity passing through. It's like if you are running with a car and you have friction with the tires and the road, the electrons, they also have frictions inside the conductors, and that's the resistance. So the equation, the formula is V equals to R multiplied by I. V represents the voltage as it measures in volts, R represents the resistance is measured in ohms, and I represents the intensity and is measured in amps. Amperes in reality, but we say amps. The thing is that we can isolate different variables in this equation, depending on what you have to guess. If we want to guess the intensity value, we know the voltage and the resistance value, we just isolate the I in this equation. So we have to transfer the R to the other side of the equal with the V. So as the R was multiplying, when it goes to the other part, it will divide. Of course, if you want to isolate the R, it's the same. You transfer the I to the other side, as it was multiplying, it will divide, okay? To finish with this video, we are going to do a really simple exercise to apply this formula. So let's remember the Ohm's law, which is V equals R multiplied by I, okay? Imagine that we have a circuit, a small circuit like this one. Let's say that we have a light bulb, okay? We know that voltage is 5 volts and the resistance in the light bulb is 100 ohms. And we want to guess the intensity value. So we just isolate the I, we transfer the R dividing, and we divide 5 volts divided by 100 ohms, and the result would be 0.5 amps, okay? So that's the intensity in this circuit. Now let's calculate the voltage, okay? So we will repeat a similar circuit to the previous one, but we don't know the voltage, okay? That's the thing we have to calculate. And the intensity is set to be 1.5 amps and the resistance is set to be 3 ohms, which is quite low, but well, this is just a simple exercise. So if we apply the formula, we multiply 3 ohms by 1.5 amps, the result would be the voltage, and that result is 4.5 volts. And finally, if we want to calculate resistance, let's do again a really similar circuit to this one, okay? And we have that voltage is 9 volts and that the intensity is 0.25 amps. So what's the resistance? That's the question. So we isolate the R, V is multiplying, I is dividing, so 9 volts divided by 0.25 amps equals to 36 ohms. So the resistance in this circuit is 36 ohms. And that's it. I hope you like this video, that you now remember better what is an electric circuit, which components can we find in an electric circuit, and how to calculate and use the Ohm's law. Leave in the comments if you have any doubt or if you want to add any information that you think that could be interesting, and of course, see you soon.